We're on page 29, and the problems we're going to do are 3C, 4A, B, and C, and we're going to do 5B, H, and J, and for number 6, F, H, and J. So starting with page 29, number 3C, we're asked to find the slope of the line. And we're going to convert this equation into the form y equals mx plus b. We're going to rewrite it so it's in this form. And the reason we do this is because we want the value of m. M will tell us the value of the slope, and here we do not have y in the form y equals mx plus b. So the first thing we're going to do is bring this 5x from the left side to the right side. So minus 4y equals minus 5x plus 3. Now we've isolated the y term on the left side, but if we divide this by minus 4, we get y. If we divide this term by minus 4, we get 5 over 4 times x. And if we divide plus 3 by minus 4, we get minus 3/4. So now the slope is the coefficient of x, the number in front of the x, which is m, and so that equals 5/4, or 5 over 4. Now we could do this in another way and convert the equation that we've got into the form ax plus by plus c equals 0. And we did this on page 25. So if you want to review your page 25, it's there. It gives this form of the equation, which is just another way of rewriting the y equals mx plus b. You can write it in the form ax plus by plus c. So when we do that, all we have to do is bring the 3 over from the right to the left, and we get it in the form ax plus by plus c equals 0, where a is the coefficient of x, 5, b is the coefficient of y, which is minus 4, and this c term is minus 3. We actually don't need the c term to compute the slope, and so we have the slope in this standard form of the equation, and we showed how to do this on page 25, is equal to minus a over b, which is minus 5 over minus 4, because a is 5, so if we say minus a, we have minus 5. B is minus 4. So we have a minus over minus, which gives us a plus. 5 over 4, which is the same as this answer over here. So to go over here, what we did is we converted the equation to the form y equals mx plus b, which is one way of giving the equation of a straight line. Another way of giving it is in the form ax plus by plus c equals 0, where the slope is calculated in this way. And it doesn't matter whether we use the standard form or the form y equals mx plus b, we get the same value of the slope. Here we're given, it's problem 29 on number 4a, we're given equations of two lines, y equals 2x minus 5 and y equals 2x plus 7, and we're asked to determine if the lines are parallel, perpendicular, or neither. So in this particular case, we have the two lines, which are drawn with a drawn in black with the double-headed arrow, And although they're not drawn perfectly, I mean to show that they are parallel. And one, they have the same slope, as we said. If they have the same slope, we know they're parallel. What is the difference in these lines? The difference is where they intersect the y-axis. So where do they cross the y-axis? This one crosses the y-axis at -5, approximately here, let's say on the graph. And this one crosses the y-axis at +7, right over here. So we've shown that these, just a visualization of these two, just to give us a visual explanation, is that these two lines are parallel, which means that they never cross each other. They'll always never cross. If the slopes are the same, the lines will never cross. And the difference here is where they intersect the b value, which is the y-intercept. Here, in one case, the b value is -5 down here. One case, the b value is +7, which is in this case. So the only difference in these two lines is, or parallel lines, is where they cross the y-axis. Now, here we're asked to determine if these two lines, x minus 3y equals -6 and 3x minus y equals 0, if these lines are parallel, perpendicular, or neither. So what we're going to do is change them into the form y equals mx plus b, and look for the value, compare the values of the slopes m. So here what I've done is I've got x minus 3y equals -6. I've kept the y on the left-hand side. I've transposed the x to from the left side to the right side and changed the sign. So plus x here, minus x on the other side. Notice these are minus, minus, and minus. If I multiply through by -1, I get 3y equals x plus 6. Now, to get it into the form y equals mx plus b, I divide this by 3. I get y, this term here, by 3. Get y, divide x by 3. I get x over 3. And here I divide 6 by 3. I get plus 2. The slope is the coefficient of x, which is 1/3, because this is really the same as saying 1/3 x. So I know the slope is 1/3. Now let's look at the other equation, 3x minus y equals 0. Now what I do is I transpose the 3x from the left side to the right side. It becomes minus 3x, multiply through by -1, y equals 3x, and here the slope is 3. So these slopes are neither parallel nor perpendicular. First of all, the slopes are different, so they can't be parallel. The slopes would have to be identical for the lines to be parallel. To be perpendicular, this one would have to be the negative reciprocal of the other. So if you turn this upside down, yes, you get 3, but it's not -3. This would have to be -3 for the lines to be perpendicular. So the lines are neither parallel nor perpendicular. We have two equations here, 3x plus 10y equals 5y, 5x plus 3y equals 1. Let's take actually this is the second equation. Excuse me, it is the first equation, sorry. Now what I've done is I just reversed this here. Put 5y equal to 3x plus 10. 5y equals 3x plus 10. Remember, if I have this, I can transpose this to this side and this to this, but I don't, if everything becomes negative, it's the same as everything being positive. So 5y equals 3x plus 10, which I've got here. I divide this by 5, I get this. I divide the 3x by 5, I get this, and I divide the 10 by 5, and I get this. So what I'm doing is I'm taking this equation and dividing each term by 5. So I get y equals 3/5 x plus 2. For the second equation, here I transpose the 5x from the left to the right. Everything else stays the same. The 3y stays on the left, the 1 stays on the right. I divide this term by 3, and I get y. Divide this term by 3, I get this. And I divide 1 by 3. Now, if you multiply these two together, we get m1 times m2 equals minus 1. Or we can just say, if I turn this upside down, the reciprocal, and change the sign, I'm going to get minus 5/3. So the product of the two slopes is minus 1, so the lines are perpendicular. So I've said it here, if you take 3/5 and turn it into its negative reciprocal, you get minus 5/3. In other words, you take the numerator here, put it in the denominator, take the denominator here, put it in the numerator, and you put a minus in front of it, then it's the negative reciprocal. So 3/5, or I should say, if you want, minus 5/3 is the negative reciprocal of 3/5. Or you could say 3/5 is the negative reciprocal of minus 5/3. So these two lines are perpendicular. Here we're asked to find the equation of the line through the point and parallel to this line. So we're going through the point this, and this is the equation of the line. Find the equation of the line through the point and parallel to the line. So we're given a line and we're given a point, and if the line has to fall through this point and be parallel to this, what is the equation of this line? So the first thing we're going to do is take this equation and find out what its slope is. So what I've done is said x minus 3y equals 2, minus 3y equals minus x, because I've transposed the x term from the left to the right, and the 2 remains the same. So now what I'm going to do is just multiply through by minus 1. So I get 3y equals x minus 2. I multiply this by minus 1, I get that. Multiply that by minus 1, I get this. Multiply by plus 2 by minus 1, and I get this. Now, dividing this term by 3, I get y. Dividing this term by 3, I get x over 3. And dividing minus 2 by 3, I get minus 2/3. So now, m is the coefficient in x, and it is 1 over 3. So I now know that I know the slope of the line, and I know it has to fall, or this point has to lie on the line. So I can just use the form, the point slope form, y minus y1 equals mx minus x1, where the m is a third, and x1 and y1 are these two values here, and that's what I do here. So first I put this m equals a third for here. Here's the m equals a third. Now, x1 is 3, but there's a minus there, so it's minus 3. And y1 is minus 1, and this minus is that minus. So be very careful with your signs here. We're substituting into this equation y minus y1. This minus is that minus. y1 is minus 1. m is a third. X is here minus x1 is 3 here. So y minus 1 becomes y plus 1, and then I have a third x minus 3. Find the equation of the line through the point and parallel to the line. So we have to find the equation of the line that goes through the origin, and the origin has the coordinates 0, 0, and it's parallel to this line. Okay, if it's parallel, we have to find the slope of this line. We convert it into the form y equals mx plus b, and we're going to find the slope, and then realize that it will go through the point 0, 0 in our calculation. So I'm going to transpose the 4x from the right to from the left to the right. It becomes minus 4x. Everything else stays the same. Divide this by 2, I get y. Divide this by 2, I get minus 2x plus 5 over 2. So the slope of this line is the coefficient of x, and then it has to go through the point 0, 0. Find the equation of the line through the point, and the point is the origin, and parallel to this line. So we now know the slope and we know the point. So we can just put it into the equation, the point slope form. Both the y1 and the x1 are 0 because that's the origin. Minus 2 is the slope, and we get y equals minus 2x. So if we want to visualize this problem, here we have our line minus 2x plus 5 over 2. So remember that b is the y-intercept, roughly here, let's say. We'll say that. And notice that it has a negative slope. This line is sloping downward. Remember what we said? So this is this one. And then the line parallel to it that goes through the intercept has to be this one here. The slope of this line and this line is the same. What's different about them is one has an intercept of 5/2, which is this one. One has the intercept of 0. Remember, the intercept is where it crosses the y-axis. So this has a value of b is 5/2. Here, this is b equals 0. Find the equation of the line through the point and parallel to the line. So here we're asked to draw a line that's parallel to the y-axis, and goes through the point 9, 5. So I've just drawn roughly the point here with an x, where x is 9 approximately and y is 5 on this coordinate system. So that's the first thing I do. And then I know that it has to be parallel to the y-axis. It says here, parallel to the y-axis. So if it's parallel to the y-axis, here's the y-axis. I'm drawing it parallel. And what this is that you can see that x equals 9 for this. No matter what the value of y, x, so if you choose a value here or you choose a value here, x is always 9 along this line. So along this line, x is 9. Remember, if you have a line parallel to the y-axis, it has the general form x equals a number. In this case, this is the number because that's the value of x. So the answer to this question is x equals 9. Let's go over this again. find the equation of the line through the point 95 and parallel to the y-axis. This is the y-axis. So however we draw this, the line must be parallel to it. Well, if it goes through the point 95, this means along this line, no matter the value of y, x always equals 9. If the equation is parallel to the y-axis, it must have the form x equals a number. So in this case, along this line here, x is always 9. (6F), find the equation of the line through the point and perpendicular to the line. We have to be careful to read this. In the last few problems, we've all looked for parallel. Now let's look for perpendicular. So here, we want the line to go through this point, but be perpendicular to this. So first of all, we convert this into the form, we write x plus 3y minus 6, which is our original equation right here. We transpose the x from the left to the right, and we divide each term by 3. If I divide that by 3, I get this. If I divide this by 3, I get this. And if I divide the 6 by 3, I get 2. So I know the slope of this line, minus 1/3. But I want the line that I'm looking for to be perpendicular to it. So instead of using minus 1/3, I'm going to turn it upside down and change its sign. So minus 1/3 becomes minus 3/1. And then because it's the negative reciprocal, I put another minus here. So I have a minus minus 3, and I have plus 3. So we know from the point 0, 5 that b equals minus 5. So we can just plug it into the form y equals mx plus b because we know the slope and we know the intercept. You see, this value here is really the y-intercept, which is the b value. So we can plug it directly into the form y equals mx plus b. M is 3. That is the slope of the line perpendicular to this one. And we know it has to go through the point 0, minus 5. When we are given in this form, this is the y-intercept. So this is the b value here, and b is minus 5. Now, supposing you wanted to use the point slope form, well, you'll get exactly the same answer. y1 is minus 5, m is 3 right here, and x1 is 0. And when you do that, you get y plus 5, because this is minus minus, gives me plus 5, equals 3x. I transpose the x from the left to the right, and I get y equals 3x minus 5, which is exactly the same answer that I got over here. So this is a very good example of sometimes, and quite frequently, you can use both equations, either the point slope form, or you can use the slope intercept form, because this is the slope-intercept form that we're using here, y equals mx plus b, and you get the same answer. So in the first problem, we've used the slope-intercept form. Here we've used the point-slope form. It doesn't matter which one we use, because here's the point, but at the same time, when x is 0, we know that this is the b value because this is where it crosses the y-axis at minus 5. So we get the same answer. find the equation of the line through the point and perpendicular to the line. So here we're given this equation. We have to find an equation of a line perpendicular to this one and that goes through 0, 0. So we do what we've done in the previous problems. We solve this for 2y, transpose the 4x from the left to the right. We get minus 4x. So we've got 2y equals minus 4x plus 5. Divide this by 2. Divide this by 2. And divide this by 2. So we know the slope is minus 2. And for the line to be perpendicular to this line, the slope will be, we put the denominator where the numerator is. We put the numerator where the denominator is, so we get minus a half, and then we change the sign and we get a half. Now, we also know that b equals 0 since the line goes through the origin. Okay, that's the y-intercept in this case. So equation is y equals a half x plus b, which is 0. So we can write this and say y equals a half x or y equals x over 2. It doesn't matter. This means exactly the same as this. Y equals a half x or y equals 2. Now we could also use the point slope form where we know x1 is 0 and y1 is 0 because the origin is, the values are here and here. So we say y minus 0 equals a half the slope, and x1 is 0, so y equals a half x or y equals x over 2. So whether we use the point slope form or the slope intercept form, we get the same answer. So this is similar to a problem that we've just done. Here we're asked to find the equation of the line through the point and perpendicular to the axis. Previously we were asked for parallel. So now we have to go through the point 9,5 and it has to be perpendicular to the y-axis. So if it's perpendicular to the y-axis, this is the y-axis, has to cross the x-axis at a right angle, has to cross the y-axis at a right angle. If the line is perpendicular to the y-axis, it must cross the y-axis at a right angle, so there's a 90-degree cross here. And if it does that, it's parallel to the x-axis. So the only thing that doesn't change along this line is the y value. If you look at this, no matter what happens, no matter what value of x you take here, if you take this, or you take that, or you take this x value, y is always equal to 5. So for a line that's parallel to the x-axis, here's the x-axis right here. For a line parallel to the x-axis, the equation is y equals a number, and in this case, y equals 5. Previously, we had find the equation of the line through the point and parallel to the axis. So now we're perpendicular. Let's go over this again. We're given the point 9,5. Here it is, let's say, x equals 9, y is 5. Not drawn to scale, but doesn't matter. X equals 9, y equals 5. And it has to be perpendicular to the y-axis. Here's the y-axis. If it's perpendicular to the y-axis, it must form a right angle with the y-axis, and therefore must be parallel to the x-axis. Here's the x-axis right here. Any line that's parallel to the x-axis has the equation y equals a number, and that number has to be this value of y here. So no matter what the value of x here, let's say this is x is 2, y equals 5. Let's say over here, x equals -4, y equals 5 right there.